Okay, here we are doing Stats and Mechanics, Year 1, Chapter 9, Question 11. The mixed exercise, a particle moves along a straight line from a point X to a point Y. Okay, X, Y, there we go. With a constant acceleration. The distance from XY is 104 meters. Okay. The particle takes 8 seconds. Let's go for t equals 0 and t equals 8 at that point there. Okay, to move from x to y, and the speed of the particle at y is 18 meters a second minus 1. Okay, fine. The particle moves on. Okay. Find the speed of the particle at x. Okay, let's have a look at the suvat on this then. So, suvat, distance is 104. The initial speed we don't know. The final speed was 18. The acceleration is constant and the time is 8. So, we are looking for looking for one of the equations which does not have a in it, so that would be the S equals U plus V over 2 all times T. So 104 equals U plus 18 over 2 times by 8. So 104 divided by 8 gives me 13. 13 equals U plus 18 over 2. Double the 13, making it 26. 26 minus the 18 is equal to U minus 18 is 8. The initial speed is 8 meters a second for U. Okay, the acceleration of the particle. So we can use exactly the same suvat in here. Okay, but this time we're looking for the acceleration, something that does not involve an initial speed. So we can use the S equals Vt minus a half at squared. Why do I use that and not use the one with the acceleration? Not the acceleration, but the one with the u in it that I just found. The reason being is if I've made a mistake in part A, then I would carry that mistake over to part B. With something like this, I don't need to do it, so why risk using my mistake there? Am I confident in my answer? Yes. Is this just a sensible way of working? Yes. Okay, right, 18 times 8 minus a half times a times t squared, 8 squared. Okay, so 104, what's 18 times 8 first? 144, so 104 take away 144 gives me minus 40 is equal to minus, that's 64, 32a, so 40 divided by 32 is 5 over 4. Which gives us 1.25 meters a second minus 2 being an acceleration. Oh, and there's a part C. Okay, the particle continues to move with the same acceleration until it reaches a point Z. At Z, the speed of the particle is 3 times the speed of the particle at X. Well, we know the speed of it at X, don't we? It was 8 meters a second. So we've got 8 meters a second on here. We have continued to move all the way up to Z until we have become 3 times the speed. So that's 24 meters a second. Okay, find the distance xz. All right, well, let's look at the whole thing between x and z. We have got a distance that we don't know, an initial speed of 8, a velocity, a final velocity of 24. The acceleration was 1.25. And the time we don't know, so we need the equation with no time in it, which is v squared equals u squared plus 2as. So 24 squared equals 8 squared plus 2 times 1.25s. Yeah, what's 24 squared? 576. Okay, 576 minus 64 from the 8 squared divided by the 2.5 from the 2 times 1.25. Okay, should equal s. So 276 minus 64 gives me 512 divided by 2.5 gives me 204.8. 204.8 meters is equal to s. Okay.